Hello everybody, I'm going to continue my Compass Straightedge mini-series about constructible numbers. So I introduced them in the last video. And we start with some specified 1 distance. We say the unit distance 1 is constructible. What else can we do? And I talked a little bit about last time the problems of antiquity. But before that, I showed you, 2 is constructible, 3 is constructible. We basically just repeat this length in a line using, a given line. And then we can sort of double the length and we can get now distance 2. And then we can get 3 and 4 and 5. See, it's fairly easy to see we're going to get all positive integers. But what can we actually do? Like, what sort of operations is our constructible is the sum of 2 constructible numbers a constructible number, that sort of thing. And so I'm going to talk to you in this video about how if I give you 2 different constructible numbers, so 2 different lengths, and I know they're constructible, I can show you that their sum is constructible and their positive difference, or absolute value of their difference, is constructible. Because remember, we can't construct negative lengths. Okay? But we can if I give you a little a and a little b, and I know a is bigger than b, I can construct a minus b. Now we won't need to use the given a unit length here. We will in the next video when we do a times b and a divided by b. But we don't actually need our 1 distance here, so we're going to sort of move them off screen. So I will suppose that I have been given 2 lengths. A little a and a little b. And I want to show you that I can make a length that is a plus b and a length that's a minus b. Okay? And you can use a parallelogram to sort of append one of these onto the other. I'm going to attach them both to a 3rd point, or not a 3rd point, I guess 5th point, just because I want to show you that at the end I'm going to do sort of a sliding these things around and show you the construction really is independent of where these lengths are and what they actually look like. So this basically amounts to drawing a parallelogram, a couple parallelograms actually. So we're going to get a parallel line through this point over here to our green line. And this is something we've done before. Several videos, and I'm sure this won't be the last time we do this. But it's a fantastic technique making parallelograms, or parallel lines through a given point. So now we draw a circle there, and that gives us the other side of the chord. And extending the whole chord gives us a line parallel to the original. Fantastic. So now we just need a line through our 5th point parallel to our red line, and we're all set. That'll get us a parallelogram, and that'll allow us to duplicate the first of our lengths. Oh, I shouldn't, I don't think I actually extended this. Did I extend this? Oh well. Alright. We're going to have to zoom out a little bit. We might catch a glimpse of, yeah, there's the 1. Okay. So now, line through there. Intersects the circle that we started with, brand new circle, get a chord, and just extend the chord. So now let's hide all these extra points and everything. Don't need them messing up our picture. Well, not messing up, but cluttering up our picture. There we go, everything looks nice now, and so this length here is the other side of our parallelogram. It's going to have to be the same length, so sort of the little a, we might almost call it. So we're going to keep the most recent line that we constructed. And what we're going to do is now we're going to duplicate this second length, but we're going to duplicate it so it's on this line. Okay, and this is what's going to be key. So we begin to make our parallelogram. There we go. Perpendicular line to our point. And then we need, I picked the wrong circle at the start. There we go. And now the chord going through there, parallel to our red line. So let's clear some of this up. I'm going to keep this circle because I needed it. I just got caught up thinking about something else. So, continue on this way. There we go. Intersections. Perpendicular lines. Intersecting the circle we started with. We'll zoom in so we can see what's going on. And now connect up our chord. And we hide our work so the pictures are much clearer. Okay, so now we have a parallelogram sitting here. So the blue point to our most recent dot is our old length, the little b length. So if I draw a circle, I can place two dots, one here and one here. And this is all that we're going to need. So this circle here has radius of the smaller little b sort of length. But the blue dot to the dot we made so long ago is a, so we've got a minus b in here. We'll give that its own little line segment length. So we'll rename this guy a minus b. Won't let me do a minus b. Okay, we'll name this one a. And we'll rename this one b. Okay, so that's a minus b. What about a plus b? Well, I'm glad you asked. We have a plus b. Let's not use the blue. Let's use nice purple. So the circle added on length b to the end, but up to the middle dot, the blue dot that's in the middle of the center of the circle, was the reproduced a. So now we've got a plus b. Okay. So we can hide our circle that helps prove all this. We can hide most of our extra dots and the line that everything's on. So now as I make a bigger, both a plus b and a minus b get bigger. As I make b bigger, the whole thing gets . something has gone. So a minus b shouldn't be getting bigger like this. Oh, I see what's happening. Actually, do I see what's happening? So it's going from this dot between these 2 points. Which it was told to do. And so this should be our a minus b. No, our a minus b should be in here. Get these back the way they're supposed to be. So a plus b is this whole length, and a minus b is this smaller length. If I move a and b over, and move this down, seems like a minus b have swapped places. This is largely just due to GeoGebra causing me problems, making a headache for me. But we do have in here the a plus b and the a minus b. I suppose I should move these guys up so that they're centered. So as I move a around, some of this will flip. And that's GeoGebra. But if we go back to the circles we constructed, we do know that we do get a plus b and a minus b. Okay? So that shows you that a plus b and a minus b can indeed be constructed. So there, if b is bigger, the whole thing flips around because the construction was a little limited. But that does it. So in the next video, we're going to do a times b and a divided by b, and then there'll be a third video where we show that you can construct roots. And that's really it for constructible numbers. So join me in the next video as we continue to explore this more advanced math concept, really. Have a wonderful day.